So everyone, welcome to this C++ language conversation with Bjarne Stroustrup in New York. I'm in Manhattan, New York City. I'm in Ashland, Oregon, and it's great to have everyone with us. And we'll just get right to it, a conversation about C++. First thing I thought we'd do is have you give us a little update on what's happening with the C++ Standards Committee. You were just in San Diego, and then I guess looking forward to going back to Kona on the big island of Hawaii in the springtime.
Okay. Just back from San Diego. I've been back maybe 10 days, and in another 2.5 months, I'll be in Kona, standards meetings. And so, as somebody said, crossing the ocean to spend a week of 12-hour working days is insanity. He's lucky. I don't get 12-hour working days. It's not that easy. And we seem to be making progress. If things work out as planned, C++ 20 will be great. It'll be as much better than what we have before, as C++ 11 was better than 98. We had progress on modules, which should give us sort of, I don't know, depending on your compiler, maybe 3 times or 7 times faster compilation speed, primarily due to better code hygiene. And the concepts are almost the way I wanted them to be. You can do it, not as pretty, but you can do most. And what else have we got? We got ranges, which infinite ranges, and now finally I can say sort of v rather than sort of v.begin, comma v.end. We've taught the standard library to actually understand a range as something that has a beginning and the end. And if you give it something that has a beginning and the end, it will take it, like v for a vector. There's some hiccups in the area of contracts that almost was, we thought it was there, but we found some problems. We'll see if we'll fix those. Unfortunately, we didn't get networking standardized. On the other hand, it's been shipping for a decade, and it has benefited for the review in the standards. So I'm sad about it, but I'm not going to try too much. I've probably forgotten something. There's lots of little things, and a lot of those are best forgotten because then you have to remember them and learn them and such. The work on compile time evaluation has finally found a target, an overarching motif. It's not just a set of facilities anymore. It adds up to support for fairly general compile time compilation and building up towards support for static reflection. So this is major stuff.
Yep.
And some of the things fits into my hope of basically making the use of C++ simpler. That is, you can't make the language simpler because stability over decades is a feature. It's one of the reasons people use C++. Their old code works, old as in 10, 20 years ago, and that gives people hope and reason to hope that their code from today will work in 10, 20 years. This is a feature, and it's a feature that new languages have trouble getting, so they can be simpler, but by simplifying, by improving the foundations of C++, we can simplify the use. It is really simpler to say sort of v than to sort of begin, comma, end. And it is simpler to write code with concepts. You get overloading, you get your error handling done right, than it is to write with fully generic things where you have to protect against somebody sending you a type that simply isn't what you had imagined. Now you can state what you expect, and you can have the compiler enforce it. This is good stuff. It simplifies use. So not a simpler language, but one that you can say things more simply in, and that compiles faster, much
Okay.
faster.
What I'd like to do is one of your favorite topics is just go a little bit more into the world of concepts. Hopefully that's coming up on the screen.
Yeah, I did.
Okay. I
And
think my other
I don't.
behind, but there we go. I mean, you had
Yeah,
mentioned that
sorry.
generic programming has been going on since the beginning of templates 20 years ago or more. And now we have concepts in. What are those benefits? What are the benefits to a programmer? What can I, as a developer, look forward to?
I mean, it has been going on since the very beginning. I wrote a paper in 81 saying you needed generic programming, and I conjectured that macros were the way to get it. Boy, I was right about this problem and what we needed, and I was so wrong about how to get it. But today we have solved it. People who are that old can remember when C couldn't do function argument checking. That is, you said square root of 2, and if you are lucky, your computer crashed. Because it didn't know how to convert an integer into a double. Well, actually, it knew that, but it didn't know it had to in that situation. So specifying arguments, specifying the requirements of a code precisely is very valuable. And that's what we will be able to do with concepts. We can say sort of something that's to be sortable, as opposed to sort anything and hope that what you gave it actually was something that was a sequence with random access and something that has less than for its element type. We can express that directly. And again, back to compilation speed. If you write with concepts, it actually compiles faster than if you use workaround like enable if and such to protect you against overgenerality. I find that the greatest benefit from concepts actually is that now you can express your designs more precisely, and you can think about your designs better. You don't make as many thinkos, and then afterwards, if you get typos and such, the compiler catches you. And it is exactly the benefits of having a good type system, having a good way of thinking about your code.
Now,
and we haven't damaged runtime performance or generality.
Okay. I was reading, and maybe I've got this wrong. There's been a conversation, maybe it was with you and Herb Sutter and others, about a convenience notation for concepts. Is that done, or is that being discussed?
It's sort of done. I never called it a convenience notation because I thought it was just a notation. I want generic programming to be as close to ordinary programming as it can be. As a matter of fact, I want it to be ordinary programming, and I wanted that for a long time. The basic design that we have now was done by me and Gabby Das Reyes starting in 2003. And that's what my keynote that you're referring to at CPPCon was about. And basically, when I say square root of double, I say I want a double. And if I say sort of something sortable, I want something sortable. When I say square root of double, I really mean that anything that can be used as a double, like an integer, can be used. When I say square root of sortable ref, I want a reference to something I can sort. And that's it. And I think there's a conversion between convergence between types and contracts. A concept. A type says how you can use an object and how you can create it. A concept does only the first part of it. A concept says how you can use an object. It doesn't tell you how to make it, because it doesn't actually, at the point where you use it, know what the exact type is, but it knows that it can use it and how. And so there's a very deep convergence going on here. And that's what I want. And for that reason, I wanted void, sort of, sortable, ref to be the notation. Some people I think they panicked. They, of course, disagree and think they're being cautious. But they wanted to be able to see whether it was a function or a template function. And my claim is that they shouldn't have to know. And there are some mistakes we have made in the design of C++, in particular an R-value reference and a forwarding reference uses exactly the same notation, and that's not right. But that means that there are a few cases where having a template or having a non-template gives a different meaning. And for that reason, they absolutely wanted to know whether sort was a template in what I just said. Void, sort of, sortable, ref doesn't tell you it's a template, unless you know what sortable means. My argument was that, well, if you don't know what sortable means, why do you say it? I mean, you don't use types without knowing that they are types, and you won't use concepts without knowing they're concepts. But that argument didn't win the day. So they insisted on some notation, and the notation that we all agreed on in the end was we have to say void, sort of, sortable, auto ref. Auto is the magic cookie that says that something is going on with multiple types and with binding of types and that kind of stuff. And so you do what I would recommend and what I talk about, and then you sprinkle auto over your code like pixie dust, and it works. It'll annoy me for a very long time because I think it's redundant and I don't like to type.
Yep.
Undoubtedly, somebody is going to propose that auto means optional, so that people who like the extra pixie dust can have it, and those of us who think it's unnecessary won't have to say it. But my guess is that there will be strong opposition there, because somebody who are afraid of concepts and templates wants to be sure that my code doesn't hide them. And so we'll leave that for there. We made huge progress. We get the design benefits. We get most of the notational benefits. And maybe when people get more used to it, they'll get less nervous.
Another big area in my mind, Gabby was heading this up with others, is the idea of modules. We have these huge numbers of header files from the past, thousands, we're supposed to be small little header files, I think, tens of thousands of lines of code inside header files. And so how do modules help us as developers?
Yeah, and thousands of header files. Basically, modules allows you to organize your code so it's modular. That is, if you import a module A and then import module B, you get exactly the same as you included module B followed by including module A. That's modularity. And if header files worked that way, it would be easier to deal with. But even if they were modular, you would still have the problem that a header file is compiled every time you see it. You get a bunch of characters that turns into token soup, and you have to reconstruct your program from that token soup. With modules and modularity, you could take your code, you can organize it in some reasonable way, and you can do that once. So where you before included a header file or 1,000 header files 1,000 times, and now you include a module, you import a module the 1,000 times, but each time it costs you absolutely nothing until you start using it. And that gives a massive improvement in the amount of code that the compiler has to look at. And I've seen numbers of the range of 5,000 times less information to process. And this, if you use modern compilers, gives you sort of about 10 or about 3 times, and it still works with parallelizing builds and all the other good stuff. So the monster header files will not go away, but you can gradually remove them and turn them into modules. They won't go away because, say, there's C headers and there's headers that you can't touch for legal or practical reasons. But we're going to see starting, well, now, and certainly more next year when Clang comes under Steam, and later next year or the year after when GCC comes onto Steam, we can take our code and start making it compile really fast. And anybody who's done that has found bugs. Because once you have this token soup with lots of macros and aliases, there are bugs in your code. You just can't find them. Modularization helps you find that.
So I think you mentioned some of these. I was just sort of putting a few other parts or other activities that were going on at the ISO CPP committee meetings, and you touched on some of those. I think reflection, some people are used to that when they're coming from other languages like Java and so on. Be interesting there. Code was listed, I think, as well, but maybe there were other. There's so many things I know that goes on in those meetings. So
I will comment on this, and let's see. Contracts are sort of runtime checks that you can turn on and off, and that's currently under debate. There are some problems were found. We'll see what happens. What is going to happen in Kona in February is the feature freeze, no new features. What happened in San Diego was we did not start processing new features, but in Kona, the gate will go down for getting things into the working paper for C++ 20. Reflection is not what people are used to from other languages. The problem with runtime reflection, dynamic reflection, as you have it, say, in Java, is that when you compile your code, you have a lot of data lying next to it in case you want to reflect on it. And sometimes that extra data is much larger than the code you're executing. And quite often you lay down data that you never actually use because reflection is used only for a few things. So what we're doing instead is static reflection. That is, we allow people to write compile time programs that introspect on the code and then generate the information you want. Quite often the information you want is actually code that does what you would do in Java by looking over a data structure, but here you just compile it directly. So if you want a JSON parser, you say JSON of X, and a little program runs in the compiler that generates the reader and writer for JSON for the types, for the JSON types, and it doesn't affect other types. So IO is one of the examples. If you actually need a runtime data structure that you want to run execute at runtime, then you say, give me the runtime representation of X, and you get it for X. You don't get it for Y and Z and things you've never heard of. So it's a much tighter thing. This will not happen for C++ 20. It's hopefully, it's planned for 23. But we'll see if we can do it. This is a big and important issue and basically fulfills sort of a lot of the state that I would like to see C++ in. I mentioned ranges. It's better algorithms for C++ and better ways of interacting algorithms with data structures. Coroutines I actually thought were done a year ago. There's some very nice coroutines done by Goran Isherov from Microsoft, and they are available today in the Microsoft implementation and in the Clang implementation. And they run really fast. They're really small. They are not trivial, but then they are a novel idea to most people. I'd like to point out that we wouldn't be sitting here talking today if it wasn't for coroutines. They were my bread and butter for the first 10 years of C++, for simulations and what today would be multi-threading. I was running 700 tasks in pseudo parallel on a PDP 1170. That's a machine with 256K of memory. So this kind of stuff is quite powerful. Unfortunately, somebody thought they could do much better than Gore's coroutines. And they have been pushing a proposal, which, as it is beginning to look more and more like Gore's coroutines. But I hope we will settle on a design, and I hope that we will settle on a design that's very close to what is shipping and production quality and is in heavy industrial use in places like Facebook. I hope we'll get that in Kona 2.5 months. And if any more tweaks are necessary, we still have about 1.5 years to get it done. I mean, just because we have the feature freeze doesn't mean that every I is dotted and all of that. And for others there, I mentioned the compile time compilation that's feeding into reflection eventually. You can do amazing things at compile time, and that's good for performance. You're getting pure functions out of it as a side effect, because anything you can compute at compile time obviously doesn't have any side effects, because there aren't any objects to have side effects on, and things like that. So that's probably should be there in the others.
Okay. And there's been this discussion. I think you were worried about the state of C++ and where it was going. There was some articles and papers that you wrote. I've been to Stockholm multiple times in my travels for business and went to the museum. And so I thought, and there's people who've said, look, C++ is getting monstrous. There's all sorts of things going on. Will it collapse on itself? And so I thought I'd give you a chance to discuss your thoughts about C++ stability and evolution over time.
Sure. We've actually been pretty good at stability. I first brought up the Vasa as a warning story in the 90s, and I'm now doing it again because one of the dangers to a successful language is over-enthusiasm. Currently, people are very enthusiastic about C++. The user population is growing. My guesstimate is about 4.5 million users, going up by about 100,000 a year. We don't hear much about that, but if a little language that was new got 100,000 users, it would be all over the web. In C++, it's just business as usual, and statistically, it's not very significant because 100,000 in 4.5 million is a very low percentage. But it is successful, and we had 181 people at the San Diego Standards meeting. I mean, I know of legislative bodies that are smaller than that, and we have to make decisions. This is hard. The more people you have in the room, the more time it takes to talk about it, the more people has to be convinced, the more people have to agree. And it's a very diverse group in terms of the areas of work they're doing. So this is difficult. Also, we had 256 new papers, and we had some leftover papers also. So we're talking about more than 300 papers we have to work through. And the 276, I did some counting, and the number of words are on the order of magnitude of 3 times the combined words of William Shakespeare. This is insane. And so I'm not saying C++ is collapsing under its own weight. I'm saying if we are not being careful and honest about this, it will collapse. However, this has happened before and it didn't collapse because we were careful and came to our senses before it happened. I guess I should tell the story. Not everybody has heard about the Vasa. In 1620s somewhere, the King of Sweden wanted the greatest battleship in the north, named after the royal family, the Vasa. And they built it and they got it well started. And then they noticed that the opposition was building battleships with 2 gun decks, as opposed to the older style that had 1 gun deck. And you can see it on the picture there, it's got 2 gun decks. So they changed it so it had 2 gun decks. So it was a good fighting ship, but it was also supposed to be sort of a prestige ship that you can sail into harbors and impress the locals. So it had to be the most beautiful painting, the most fancy statues on it. And they should have gone back and modified the foundation a bit. It needed a slightly bigger keel and a broader bottom, but they didn't do that. They didn't have time. They told the king that they needed some more time and they should rebuild it. And back comes the standard thing from high management. The king says, you do that or else. And so they built the ship and it was beautiful and the trumpets blaring, the people on board. They went out in the harbor of Stockholm. They got half across. A gust of wind came, it keeled over and sank. And it was hidden for 300 years down at the bottom of the sea and it's fished up again. And I don't really want C++ to keel over. So I'm warning people and I'm giving lists of things and saying you can't have all of this. You can't have everything you want. I can't have everything I want. We need something that is an improvement and not something that's just a prestige project.
So another resource that I find to be really helpful is available on GitHub. And I think this is something that you and Herb Sutter, and maybe others, have been working on, about trying to give guidance to developers who want to use the language. Is that what the core guidelines is all about?
That's what it's all about. It fits in several places. When I came to work at Morgan Stanley, one of my things that I'm doing is to help people modernize their code base. And so I also saw people being enthusiastic about C++ 14 and 11. And I decided that people were doing really weird things because they were modern and fashionable, and other people were confused about what was a good use of the new features, and other people didn't want to touch the new features because they were new and didn't know how to use them. And so I started writing some guidelines. And then I found that other people were doing similar things. Herb and other people at Microsoft, like Gavidos Reyes, were trying to help the Microsoft users to more modern things, and found that some people at CERN were doing exactly the same thing. So we said, okay, let's make it an open project. You can find it on GitHub. You can submit suggestions and all of that. There's a group of editors that approves improvements on it. And so that's good in itself. But think about it this way. We talk about how complex C++ is and how we can't simplify it by throwing away old features. So it must keep growing, but we want it to be simpler to use. We can do that in a couple of ways. One is to provide simpler syntax, like concepts makes generic programming simpler, ranges makes ordinary use of sequences of objects simpler, and the other way, for state, the range 4 makes it easier to use ranges. But we need a guideline. So we need guidelines like saying, When you want to use, when you want to traverse a data structure, use a range 4 if you can, and why. That's the kind of thing the core guidelines is. So it tells you what kind of subset you're interested in for certain benefits. And key things in that is an underlying model of resources and lifetimes. So you have static checkers that will tell you if you have a memory leak. It will tell you if you have a bad pointer, doesn't point to anything and things like that. And it's not perfect, but it's getting better every year. And the guidelines doesn't cover everything for everybody, but they're getting better every year. So it's part of this push to make use of C++ simpler.
So it maybe the question, because I saw a couple questions coming in about, one of the questions was about, how have you seen the developers using C++? How have they changed over time? I mean, you've been, in teaching in universities, you've traveled the world speaking at conferences, you're doing work and helping the developers at Morgan Stanley. Have you noticed how things have changed over time for the developer? Or people old and newer code, or starting from scratch using, what's the term you always use? Modern C++, I guess.
Well, yeah, modern C++ I define as good use of the latest release of the standard. So what is modern C++ to me today differs from what it was 3 years ago, and it will differ from what it will, and in 3 years it'll differ again. It's not sort of here is a point in time and this defines modern, because that's ridiculous. Modern is a relative term. People are all over the place. I can't generalize over 4.5 million people. There are people who think that C++ is C with a few weird unnecessary features added. There's people who think it was a failed attempt to create Java or Python or Haskell. And there are people that write code based on such assumptions. So you can go and see people that really, really are writing C, maybe with a few little things to do with it. There's people that try to put everything into a class hierarchy. That was never the idea. And there are people that write fully functional code. You can actually do that. And if your problem is fully functional, well, you can write really good C++ for it and run it probably faster than the functional languages. And similarly, yes, if your problem is hierarchical and requires dynamic resolution of types, then class hierarchies, what you could do in Java, becomes a fairly reasonable way of using C++. But people are all over the place. But I think, by and large, too many people suffer from very old-fashioned use of C++. This comes because, well, teachers tend to not have time to upgrade their knowledge. Students read old books, students read old code. People get coding guidelines that was designed for the 90s. So I think my job is to bring people up to sort of C++ 17 or thereabouts 20, and without going mad with new features. The purpose of the exercise is not to use the most and the fanciest features in the strangest ways. It is to write good code, use the features that are most appropriate for your problem. I wrote a book recently and updated it called A Tour of C++. The job of that book is to try and show people what give an overview, a tour of C++, that people can get to know what it's meant to do and roughly how, as opposed to knowing every little detail. I mean, you need enormous, monstrous books to explain everything. My latest is 1,300 and some pages, and if I wanted to upgrade it, it will be 1,800 at least. And that's not what most people want. They say they want all the details, but what they really want and need is an overview, because what you can easily pick up on the web is any detail. You go to cppreference.com or something like that, and you'll find the manual, you'll find the rules. What you need is something that guides you through it. You can use the guidelines, but it doesn't actually sort of teach specifics, and you can use the tool of C++ to sort of give you an overview. It can be read in a weekend. It's 240 pages. It's complete with the standard library. And so again, I'm trying to simplify use, and I'm trying to bring people up. The guidelines, the tour, is all responses to observing that people are all over the place with the use of C++.
So here's another.
I should mention.
Go ahead.
I should mention one thing in this context. The standards committee is starting to get more ambitious in things. So we have a tools group that is looking into tools, not just language things. And also we now have a study group for education, trying to create a resource for teachers and students. And one of the problems with teachers is they're usually overworked and they don't have time to upgrade their stuff. It'll help them. Students who want to learn C++ can't find the good stuff among all the crud, and will help them.
So it's not just hardcore syntax. That's great. I'll take a look and see what's going, especially in the education group. That's excellent.
Yeah. But it's actually now on isocpp.org. If you go to standardization and look for working groups, you can find references to it.
Okay, I'll put some links up after this session as well. Here's a question. Will C++ ever be complete? Will the standard and the language be done forever, or is there always something to think about besides the thinking?
It's a living language. Will English ever be finished? Will there ever be a final version of English? So I think the answer is, as long as it is in use and being used in new and interesting ways, or have to meet new challenges, as long as the world is changing, the language will have to change and the library will have to change. My guess is that the core facilities will become more and more stable and the libraries will become more and more plentiful. But sort of perfect lack of change is no. I mean, in the Middle Ages, you could learn your father's profession and teach it to your son, and that was all there was, because, well, that was all there was. These days, we're making progress. And with progress comes a certain amount of instability, having to learn new things and have to change. And then you get the problems with also maintaining stability too.
I know, we've had these discussions 2 other times during these Code Rage online virtual conferences. And one of the conversations we had, I forget if it was in 2012 or 2014 or somewhere along the way, was about user interface, graphics, those areas that have to do with device, these devices that we have and so on.
Yes, that's your specialty. It's not mine. I know very little about real GUI and real graphics. I tend to focus on lower level things, not because the lower level things are more important in a fundamental way, but because that's what I know about. And I wish we had more support. But each time we try, something happens. Like there's a discussion currently going on about it. If we are going to have simple graphics in GUI, does it have to be good enough for the experts in Hollywood that makes movies? If the answer is yes, it is not good enough for the novices. But if it's good enough for the novices, it's not good enough for the real experts. Should we split the graphics GUI world into 2? I wouldn't mind too much because currently we are split into about 25. But yeah, no, I don't see massive progress in that. Maybe some little progress, and we're certainly thinking about it. But the track record is not great.
The other discussion,
Fortunately, there's other things than the standard.
and the other another thing that we had discussed in the past was using runtime libraries, using the libraries to test out ideas as well before they either get swept into the standard, whether it was a standard library or into the language, the sort of boost libraries and so on. I was wondering if there was anything that is going on in those worlds that might creep into the language and the standard library in the future.
There's certainly a lot of experiments going on in the libraries, Boost and elsewhere. The problem is that it's hard to get across the library language barrier. People tend to build libraries that are sort of more elaborate and take into account things that they can't do well in the language, and then they do it in the library, and then they want to do it in the language in the way they did it in the library. So it's not actually that easy to move across. We lately saw the addition of any and variant and optional into C++ 14, or was it 17? I can't remember these things anymore. But we got them. But they look like libraries. Whereas I have this sneaky suspicion that if they had been designed for language, they would have been better and more consistent. Same kind of thing with pair and tuple. That is, it is a really useful facility to experiment with libraries, and we get a lot of experience, but it's hard to move it into the language. I think we did it right with lambdas, where we used lambda libraries for experimentation, and they never were fast enough or elegant enough. They could do amazing things, but we could do better in the language than we did. And I think we have to think a little bit harder when we move things from a library into the language.
Yep. Okay, there's another question that came in advance, and I think we've discussed some of this topic about people's perceptions of complication, people's perceptions of the language and how to approach it. Just the question here is, should C and C++ be simplified in the future, or is that just the nature of technology advancing and language advancements and so on?
Yeah, you heard my conclusion. You can't simplify the language because people want a simpler language with just 2 more features, and whatever you do, don't break my code. And this is impossible. And so we're not going to simplify by breaking changes. We can't afford that. That's just the way you destroy a user population. On the other hand, we want simplicity, and you've heard my way out of this dilemma. Coding guidelines, better teaching, tool support, like static analysis. And I hate to see the C/C++. There's no such language. The other thing is that the platforms are getting more complicated faster than the languages. And that's one of the drivers. Like, we need to deal with hardware really well, but the hardware is getting weirder and weirder because single processor performance is going down. And so we need to deal with caches and multi-threads, multi-core, virtual, this, that, and other, NUMA architectures, all of this kind of stuff. We have to address it. So C++ will get steadily bigger and more complicated in totality, but nobody uses the totality. We have to focus on how to use it with the appropriate amount of complexity for the particular problems that we're facing.
Sorry about that. I didn't realize that phone.
And by the way, this is nothing specifically to do with C++. All languages start out simple, and then they grow in complexity and power. I mean, Java was pathetic when it came out, and it is far less pathetic now. It's also 3 to 4 times bigger.
Yep. And the libraries, the number of APIs.
Yep. Yep.
Way up.
Yep.
Yep.
The world is more complicated, and it's getting relatively more complicated than the language and the core libraries.
Well, I think before the multi-cores, and you were doing some. I guess that at Texas A&M, there's still the parallel programming research group, right? And
it's mostly dissolved. The key people are moving to University of Illinois, Urbana-Champaign just now, and the rest of us are scattered. There's me in Manhattan. Gabby Does Reyes, who's a part of a lot of this stuff, is at Microsoft. The module, the fundamental data structures on the modules was something Gabby and I did in Texas, and he did it at Microsoft. He's also involved in the compile time computation. Constbexter and such is him and me again, and so we're scattered.
Yeah, and when
but
I look,
our ideas scattered with us.
That's even better. Everyone can infect whole other groups of researchers and students and graduate students and developers. When I was thinking about some aspects of, if we go back to register variables back in C, that hardware implications or architecture implications of what goes on, parallel programming, as you talked about networking and the architectures that we deal with, these vast networks and so on. I think you're right to say that as hardware, software architectures and other things continue on, the language and libraries and supporting systems, tooling, and so on are going to have to continue to evolve over time.
Mm-hmm. Yeah. Yep. Yeah, distributed computing was my PhD topic, so I've always been in that field. Before that was machine architecture.
So I remember many years ago, we were on a panel, I think it was at software development, and there was this guy that was a Smalltalk person, and Smalltalk could do everything, but I think the conversation that we had was about, when is it time to have a standard versus work on something inside of one company and leave it in there? And you mentioned you need enough people who are using the language, enough tools where people are building tools for the language and so on. And now there's ISO CPP, and we said that would go along for some time. You've been doing this for a long time. Is there an end in sight for you, or is it just so much fun that you'll continue doing this for a long time?
Undoubtedly. I mean, we haven't developed the eternal life mixture yet, but I'm still having fun.
Okay.
Not just with building the language, but with using it. You can't design and not also use. That becomes sterile.
Yeah, that was ANSI extended Pascal. There was only one compiler, and no one was using the language, but there was a compiler built at DEC that went to.
There was two ANSI standard Pascals, and neither of them were Turbo Pascal, which was the only one anybody was using.
Yeah, that's when I did my time in ANSI Pascal and extended Pascal. Oh well. But I know that these things are fun. I wonder how you can, and all the other members of the committee can find the time to read all the papers and to come together and have these conversations in such a short period of time.
Of course we can't. I mean, some of us are trying to know what's in all the papers, but most people know they can't. And the rest of us know we can't go into details with everything. So that is a problem. It's a big problem.
So concepts is
hence the Vasa stories.
Yep. What is on? Do you have a list, maybe on a whiteboard or somewhere, of a few other? You've mentioned some C++ features that you would, are looking forward to in the future versions of the language? Is there a list that you have, or a list? The committee has a nice map if people go to the site of where things are fitting into the future, right? Into future plans.
I had a plan for what C++ 17 was to look like. In I think 2015. And if you look at that list and then you look at the outline of C++ 20, it's getting there, but it isn't there completely. And I'm sort of loath to looking too far out in the future. Then it becomes, in some sense, too easy because it's science fiction, and you don't have to explain exactly what it is or exactly how you get there. The things that are missing from my C++ 17 list, static reflection, which I think we're getting, function style pattern matching, also known as list comprehension and such, is on that list. And I did some research on it in Texas and showed that I could write a library that ran as fast as the functional languages. Just think what we can do if we use the compiler. And I wanted to be able to deal with things on the stack that I knew was on the stack, so that I couldn't as easily get race conditions and things like that. Those are three things missing from my 17 list, and they are roughly the kind of things that I would like to see in, say, 23 or 26. I don't have any sort of grand plan. I'm worried about grand plans because the idea is you do what you know how to do well. And then you see what happens, you fix what you didn't get quite right, and in the process you get more ideas. This is known as feedback or engineering, as opposed to trying to solve all the world's problems in one fell swoop.
So want to make sure there's enough break time before the next session, but do you have any final words, any parting words of encouragement for the C++ developers that are on this session or who might watch this in the future? Something to cheer them on and make them feel a part of the C++ community and moving forward?
I'm not sure that's my strength, but C++ is great, and it's getting greater. And it's not just the language. We're getting better libraries, and we are in particular getting better tools. I mean, you just put the core guidelines up. When we get the static analyzer and the core guidelines a little bit further forward, like next year, the year after, you will be able to write code that are guaranteed type safe and guaranteed resource safe. No corruption, no leaks. Boom. Now that's a grand vision, and it's not new, but we're getting there.
Well, I want to thank you, Bjarne, for spending this time with me. Thank you for answering the questions and for the discussions about the features and where the language needs to go. I'm a big believer in giving great tools to developers as well as giving them guidance. And so it's great. Yeah. Thank you so much for joining us today.
Okay, it was a pleasure. Thanks.
Okay. Bye. And bye, everyone.